Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how do you use stoichiometry to convert from one substance to another when you're told that certain equations have a percent yield of a certain amount. So let's get into this. So normally when you do stoichiometry, you're assuming that everything is working out great, and you're assuming that you have 100% yield each time when you're doing a reaction or when you're doing stoichiometry. But in this case, we're going to have some percent yields that are less than 100. So let's look at how to do that. So in this problem, we're asked how many grams of CH4 methane are needed to form 112 grams of the CH2Cl2. Assume there is an excess amount of the Cl2, the chlorine. And they give us these two equations. So equation A, we have methane that reacts with uh, chlorine to form your chloromethane plus HCl. And we're told that this reaction has an 82% yield. What does that mean? So to say that a reaction has a yield or an 82% yield, or a yield of a certain percent, means that it only gives you 82% of the the full theoretical amount that you should get if it was 100% efficient, right? So what they're telling us is that we could calculate the amount we should get using stoichiometry, assuming 100%, and then whatever that is, only 82% of that is going to actually be yielded. Okay, so what does that mean? It means that we lost 18% somewhere along the way. For whatever reason, we didn't get 18%. We lost 18% somehow. Okay, so here, this reaction will only give us 82% of the theoretical yield that we should get. And then here we have the chloromethane reacting with chlorine again to form the CH2Cl2 and the HCl. And this reaction is only 65% efficient, or it only gives us a yield of 65%. So again, how do we use these in our conversion? They're telling us that we have yielded 112 grams. We want 112 grams of this product here going through this process. Okay, so how do we make sure, given that the first reaction is only 82%, yields only 82% efficient, and the second one is only gives us a yield of 65%, how do we guarantee or make sure that we have at the end of the day 112 grams of this CH2Cl2? Well, we have to work backwards like we normally did. So if they gave us 112 grams of this and they want to know how many grams of CH4 do I need to add, or how many grams of CH4 or methane do I need to begin with, we would just use stoichiometry and say, we'll convert this grams to moles, use the mole ratio here, right? And then when we get the moles of the chloromethane, then we'll use the mole ratio between chloromethane and methane again to get to moles of methane, and then use molar mass to convert to grams of the methane. But now we have to add to that these yields here. Okay, so let's go ahead and get started. So we're going to start with 112 grams of the CH2Cl2 dichloromethane. And we want to use stoichiometry. So if we're going from one substance to another substance, you got to use the mole ratio. And so the only way you can use mole ratio is if you have moles, of course. So the first thing we need to do is get this to moles. So the first step is to use the molar mass of our CH2Cl2. And we got to look that up or add that together. And when we do that, we get 84.927. Okay, but before that, we have to take in consideration the 65% yield. So this 112 grams, remember, we want the 112 grams at the end of everything. We want to end up with 112 grams. Well, remember that 112 grams is only a yield of 65% of what you should get based on what we start with here. So based on what we start here, we only get 65% of this. So this 112 is only 65% of what we theoretically should have gotten. So we lost 35%. So we need to make sure we get that 35% back. So we have to add 35%. So this gram amount is the 65%. So we're going to have to put the ratio, we're going to have to use this as a conversion factor. Remember, 65% means 65 out of 100. What does that mean? In relation to mass, if this is a percent by mass, then that means that out of 100 grams of what we should have theoretically gotten, we only got 65 in actuality. So this is the actual yield. So out of 100 grams of theoretical yield, we only got 65 grams of the actual. So this is the actual that we want to get. Well, that's going to be related to the 65 grams of actual that we get here. So I'm going to put ACT for actual. And so the CH2Cl2 actual, actual. And then that's going to be related to the 100 grams that I should have gotten theoretically. So this would be CH2Cl2, and I'm going to put T for theoretical. Yeah, that's a good way to do it. I'll do A and T. So A for actual. So this will be actual. This will be actual. So out of 100 grams that I should have theoretically gotten, I only get 65 grams. So since this is actual, I have 65 grams of the actual on top, and then I have the 100 grams of the theoretical on the top. So here on the bottom, I have actual, on the top I have theoretical. So grams of the actual is going to cancel out. And now I have grams of the theoretical. Now I can use the molar mass. So I'm going to convert this to moles. And for the moles, I have a molar mass is 84,927. So 84.927 grams of this CH2Cl2. And again, this is T for theoretical. And then 1 mole of the CH2Cl2 on top. So now the grams are going to cancel out. Now I have the moles of the CH2Cl2. Now I can go ahead and use my mole ratio. Now, just to kind of mention something really quick, I could have done the percentage after the moles too, right? The percentage applies to moles as it does grams. So if I would have switched these around here, I could have put grams to moles here, and then instead of grams, I could have done moles for the unit. I could have 65 moles and under 100 moles. So either way, it works. The yield percentage works either way. It works with the mass and it works with the moles. So I did it with the mass. And so now we got moles here. So now I can use the mole ratio to convert from CH2, the dichloromethane, to the chloromethane. Okay, so now I can use the mole ratio, and that mole ratio is 1 to 1, right? So 1 mole of CH2Cl2 and 1 mole of CH3Cl. And so that moles cancel out. And so now I have moles of the chloromethane. So now where did this chloromethane come from? This chloromethane came from this reaction here. So now we have to pay attention to the 82% yield. So whatever came from reaction A, that was used in reaction B. But we have to keep in mind that whatever came from reaction A is only 82% of what should have come. Okay, so now this amount here, this moles, is actually 82% of what should have been yielded by the first reaction. So in order to make sure that we end up with 112 grams, we need to factor in this 82%. We have to give back the 12%, or I'm sorry, the 18% we lost. So we can do the percent yield here. So again, this is going to be the actual amount that we got from the first reaction, but we want to convert that to the theoretical amount that we should have gotten. So we're going to use this percentage again. So remember, what does 82% mean? It means that out of 100 grams or 100 moles of the theoretical yield we should have gotten, only 82 moles or 82 grams would be actually yielded. So since we have moles here, we can use the percentage in terms of moles. So this is actual. So then we're going to put the actual on the top. So out of 100 grams, actually it's 82 grams or 82 moles. So we're going to put 82 moles of the CH3Cl on the bottom. And we're going to put 100 moles of CH3Cl on the top. And this is actual, and this is theoretical. So then the moles of the CH3Cl actual get canceled out, and now we have 100 moles of the CH3Cl that we should have gotten theoretically. So now that we have taken into account the yield, now we can go ahead and do our mole ratio with CH3Cl and CH4. And let's see. And here we have 1-to-1 ratio again. So 1 mole of the chloromethane and 1 mole of methane. So we're going to continue that down here because we don't have room. So we're going to have 1 mole of the CH3Cl on the bottom and 1 mole of CH4 on top. So moles of the CH3Cl cancel out. Now I have moles of the methane, but we want grams. They say how many grams? So we're now use the molar mass of methane. So the molar mass of methane is 16.043. So 16.043 grams of methane, over 1 mole of methane on the bottom. So moles of methane cancel out. Now I have grams of methane, which is what they want. They want to know how many grams of methane are needed to form 112 grams. So now we can calculate the amount of methane we would need to actually form and make sure that we have 112 grams of the CH2Cl2. And so when we do that, all we need to do now is multiply by everything on the top, divide by everything on the bottom when we get our answer. And when I do that, I get 39.694, 39.694 grams of the methane, CH4. Now, significant figures, for those of you who are interested in significant figures, remember that the rule when you're multiplying and dividing, your answer should have the same number of significant figures as the least number of significant figures in your measurement. That's not exact. So we have 3 sig figs here. Oops. 112. Here we have 2 sig figs. Here we have 5. This is exact. Here we have 2 sig figs. This is exact. And here we have 5. So it looks like the least number of sig figs is 2. So when we round this, we're going to round this to 2 sig figs. So 3, 9, we're going to cut it off. So we have a 6 here. So that means we round it up to 40 grams of CH4. And so that, ladies and gentlemen, is how this problem is solved. I hope you enjoyed this video. If you did, then please like the video, share the video, hit that like button somewhere over here. If you wouldn't mind doing me a solid, support the channel by subscribing. Hit that notification bell. When you do, make sure you click all so you can make sure you get all my videos that I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you want me to cover, put that down below. I would love to do that for you. Thank you for joining me. Have a great day.